Greetings and welcome to the RC Wallet Vacuum channel. Today's video I'm going to do a little follow-up on the random ramp. I've done some modifications to it and go over that a little bit, and then I want to go out and do a little live test, a little demo live test. And it's kind of crappy outside. It's nice, it appears nice out, but it's pretty muddy, so I'm going to do it right in the other part of the shop and see how that goes. I ended up taking and sealed off the back of the sheet metal here. I wanted to brace that up. Like I said, I didn't have a brake to bend that whole width. So anyhow, I got that braced up. But the big thing I wanted to cover today is the vision for the vehicle. I got the accelerometer, that's been working good. The motor drive's been working good, but I've had issues with the vision for it. So it's got kind of a Cyclops look going on now, but it seems to work a lot better. The last time when I went out with it, I just had like an RC, I think it's RCWL Doppler sensor sitting off to the side to test to see how it was going to work. I wasn't sure how it would work on this reflective surface, and et cetera, et cetera. And it didn't. It worked all right in the shop. It was hypersensitive, but once I got up in the field, it quit working. So I had to use a PIR sensor to finish the test off. So the RCWLs are omnidirectional, and you really can't change a lot with them. You can get in the back of them and solder some resistors in, some little surface mount resistors to change some of the specs on it, but that's a pain in the ass, and I don't want the omnidirectional, I want it more directional. I had thought about going to a millimeter wave, but I do have some millimeter wave ones, but I haven't tried them yet, so I'm still sticking with the microwave Dopplers. And this one here is from DF Robot. It's a SEN 0521. Nice thing about these is you can program the parameters right directly through a UART on it. So you just basically tie the TXRX on the unit here down to your TXRX hardware port on whatever microcontroller you're using. In my case, it's an Arduino. And you can set the parameters. And the only three parameters I cared about were the latency time for the on-off, and then the sensitivity, and the distance that it could actually detect. I think I'm down on sensitivity. I got down to 1 out of, I believe it's a 1 in 9. I'll get that data later on in the video. And then the range, it goes out to like 11 meters. I got it down to I think 3 meters, and I'll probably still play around with that. And the latency I got to 0. I want that thing to shut as soon as it sees something or it stops seeing something. It shuts right off. I've had a lot of issues trying to get this thing sorted out with the software and the timing. I did end up putting this mount on here. And it's set up so that it has protection from, if the vehicle hits it, it can compress this way and also this way. This way is also allows me to change the angle of vision that you get with it. I obviously have a fully reflective surface. I was expecting to have all kinds of issues with this, and I really haven't been that much of an issue with that. Where I have had a lot of an issue with is vibration. So this spring setup does help to dampen it out, but I've had to deal with the vibration faults triggering with basically time delays and some other software tricks in there as it's moving. Once it's sitting here, it's fine, but as it's transitioned back into the home position, the thing wobbles around and it causes all kinds of crazy faults triggering. So I have to lock it out temporarily until it stabilizes. And there's been some other issues I had to take care of, and so I'm going to take and package this thing up. I got to put some wires in here, and I'm going to put it outside in the shop floor, and we'll give it a test and see how this vision is going to actually work. It definitely is way less omnidirectional. You got to come in from a decent angle to actually detect it. I still probably have to work on the timing a little bit, but let's give it a try. So I got it set up out here. I did go part way outside with it. It's just a little muddy, but not too bad. So anyhow, like I alluded to earlier, there's the three parameters I set on it. It's going to be the latency time, the range, and the sensitivity. So sensitivity gives a range from 0 to 9. I have it set on number 1. I don't plan on changing off of that. It's more insensitive enough. But range I have been changing. I set up initially at 2 meters. That range is from 0 to 11 meters. So I have it. I had it originally set on 2 meters, and just by me to trigger it, I had to stand like at the edge of the ramp. I didn't test it with a vehicle. I'm guessing it wouldn't be much. It would be probably less than that. So that's pretty close, relatively speaking. So I did go through and change it out to, I believe I got it in 8 meters now, which obviously 24 feet. Now I tested it with my own body, and easily 22 feet inside the shop it was triggering. That's with a lot of other interference like ATVs and tractors sitting around here. So I got a push thing outside, and now I got the sledge on there, and I can get into I get about 17 foot in front of it with the sledge, and it'll trip. So that's not too bad. I think that's pretty decent. Right now it's already been tripped where the sledge is sitting, so I'm going to run up on her just enough to, well no, actually I run across there, give it a quick jump, and then that'll reset it, bring it back to home, and I'll bring it back into the shop, and then see what range it triggers at again. There, it's homing back down. That was actually a really good jump too. So right now the sensor's set to ignore any other activity around it. So I'll get the vehicle set back in here. Now it should be out of the range of the sensor. I gotta give it a couple seconds to reset. I should be able to creep towards the. Let me zoom in on this. I should be able to creep in towards the ramp and get it to trigger. Right there's about 17 foot. There it goes. Reset all right. Back this thing up out of its range. Let it set for a second. And we'll start creeping back towards it. There's 18 or 7, right there, okay, 17 it tripped. I'm going to reposition this thing so I can get some of the jumps. All right, so we got a different angle on here. Let's give this another shot. All right, they're at 17 foot again. Let's reset. It's rehoming. Probably tough to see on the camera that's actually moving, but it is. So we'll try this shot from a different angle so you can see the mechanism working. If I line up properly, let's give it a go. Oh yeah, that worked pretty good. So for the last shot here, I'm going to just take and give a nice close-up shot of the vehicle entering and resetting the unit without actually jumping it, just so you can see the mechanism in function. So that was just the second official test on this thing, and it actually has been working pretty good. Most everything was verified on the first test. The vision was the issue I had in the first one, and now the second test seems like that's working really well. Just some more fine tuning, and like I mentioned, I want to epoxy that sensor into its Cyclops eye thing, just to protect it a little bit better. And do a bunch more testing. And as spring comes around, I get some more testing on it. I'm going to do some more detailed videos for electronics nuts out there. You want to dive into what's involved with this if you're looking to build your own, or I may even consider trying to refine this a little more and actually try selling some of these things. But if you're interested in progress of this thing, stay tuned. Feel free to subscribe, like, comment, whatever. It's all good. But in the meantime, thanks for watching.